Why, hello there. I didn't see you coming in. I'm just here reading my favorite class book. Oh, calculus. So interesting. What is that? You need help on one of your silly problems? I'm far too busy studying for my many classes. Oh, it's for a grade? Come on in! How about I teach you about the time that I found the derivative of a function using the limit formula. Come in, shall we?
Okay guys, so this is how we do this problem. I have my problem over here and we are going to begin. So the problem states that for the function f defined below, prove whether or not the function is differentiable at x equals 1. So first step, okay, and the second step is if it is differentiable at x equals 1, then state what f prime 1 equals. So there are two steps to this. We first have to see if it is differentiable at x equals 1. After that, we need to plug in to the x equals 1 to that derivative and see what it gives us, if there is in fact a derivative. And we can't use our derivative rules to answer this. We have to use the limits, the dreaded limits. So let's set this up. First of all, we have to check which one of these functions gives us x equals 1. As you can see, it's pretty obvious that this first one right here gives us what we want, because x is less than or equal to 1. So what we're going to be working with is 3x2. So let's put here f(x) equals 3x squared. Okay, so as we've known before, we know that the limit as h approaches 0 is, let me fix that, sorry, there we go, straighter line, is f(x) plus h minus f(x) all over h. Now we can see pretty soon that there is a problem. We have 0 here, we can't plug it in directly because if not we'll have an undefined function. Therefore we're gonna have to play around with this. So let's first set it up. Let's have the limit as h approaches 0 is 3x plus h squared minus 3x squared all over h. So the first thing we want to do is play around with these numbers. Let's simplify the numerator so that we can see if we can cancel out h. So we have the limit as h approaches 0. We have a straight line here, not straight but close enough. 3x plus h. Have this again, x plus h. So pretty much I just expanded it. Minus 3x squared all over h. Now I'm gonna use my FOIL method to answer this. Now we are gonna have this equals the limit as h approaches 0, and that is 3 x squared plus 2hx plus h squared minus 3x squared, all of this over h. We're gonna make this equal limit as h minus 0, well, close enough, 3x squared plus 6hx plus 3h squared minus 3x squared all over h. So does everybody understand what we're going on? If you don't, please raise your hand. Okay, nobody raised their hand, but I'm going to explain anyways, just in case. We have here this, we expanded it so that we can have it twice. Then we have this through FOIL, xx, x and h, hx, and h and h gives us this. Then we use distributive property to multiply each of the terms inside the parentheses, and now we notice that 3x squared is twice, and there is a subtraction sign. So we can actually cancel those out. So h 0, we have 3, no, my bad, let's leave that, 6hx plus 3h squared all over h. Now we're gonna have to simplify that a little bit further. We're gonna use distributive property again to remove out the like terms. We have h and we also have 3, so let's do those. Limit as h approaches 0. We take out 3h to leave x plus h inside. My bad, forgot the 2 there. All over h. And now we see that we can actually cancel the h's out. Now we cancel the h's out. Let's use distributive property again one last time. The limit as h approaches 0 is 6x plus h. Well, you look at here, now we can actually plug in h as it approaches to 0. So we actually have that the limit as h approaches to 0 is 6x. This right here is our derivative using the limit. Now that we have our derivative, we can actually show step 2. So now we have the derivative. So we know if we got the derivative, of course it is differentiable. So now let's go to the second step. Let's remember this number here, and I'm gonna delete all this. Okay, so now we had that f prime of x, which means that derivative is 6x. If you wanted to use your differentiation rules, you could actually see 3x squared, you move it over to make 6, and it's 6x, so we actually did get it right. So now we have to find what f prime of 1 equals. So we're gonna have f1 of f prime of 1 equals 6, 1. And now this is the hardest part, because now we have to multiply 6 times 1. That is really difficult. Done. So now we know that at x equals 1, f prime 1 is 6. So what does this mean? This actually means that this is the slope of the tangent line of that function. So if I were to draw here really quickly, that's our y, this is our x. Like my sound effects. Okay, for the sake of this example, I'm gonna ignore the coefficients and everything, so I'm just gonna draw x squared. That's about it. So let's say this is 1. Then of course my graph is not drawn to scale, but this line right here, which is our tangent line, supposed to have a slope of 6, which really helps us notice, because if you notice, if we were to take the slope at different numbers, like for example 2, let's put here 2, then we're gonna have to plug this in. F prime 2 equals 6, 2 equals 12. So you can actually get a really good picture. That was a horrible line. Let me try that again. We can, that's better. Then this one would be m equals 12. Really important, because with this we can actually see how much it's changing over the graph. So that's pretty much how you do it. Just remember your basic rules. Remember that limit of h. In fact, I'm gonna just do this in another. So basically, what are the steps? Number 1, set up your nice little limit differentiable thing equation, fx plus h minus fx over h, and solve this. Use whichever x that you need, the function that you need to use at the moment. Step 2 would be use the derivative to, let me not write cursive, use the derivative, so let's write d over dx, and plug in whichever value, you want the slope. And that's pretty much it. It's really easy. It is really important. It's our fundamentals in calculus, so it's really important to get a grasp of these, so that in the future you will be able to succeed in all your calculus. Now it's not writing my pretty uppercut. So thanks for everything. Francisco here. Let me sign off. Get it? I signed off. I'll be quiet now.